record on this computer. So what we're going to do this week, especially on Thursday and Monday, on Thursday specifically, is that we are going to do a update for the project. Just fill out a short form. I'll actually send it out today. So let me go ahead and actually put that on my reminders so I actually do it. Okay. Send out the, and basically this will be to tell me how effectively you've been doing your project, if you've been able to meet your expectations or not, or plan on making your expectations. The final project is due on the 7th. So part of learning to do these big projects is, by the way, to learn basically, oh, I think I can do that. That looks pretty simple. And to realize that it's a lot more difficult of a problem than you thought. It's not something you can, I can tell you that basically things will be more difficult, but until you experience that for yourself, it's a completely different thing. Furthermore, you know, it's also a great experience to push through it. When is the final exam? I've mentioned that already, but it's not on the 7th. It's sometime after that. I'll get to the final exam in a second, though. So final project, we want it on the 7th. If you can get it done in the amount of time, you can change. It would probably be more effective if you all submit, basically, even if it's the same thing. That way I can, that way we can go through it a bit easier and see who submitted stuff and when it was submitted. Okay. Yeah, that sounds about right for the final exam. All right. And so by getting it in on the 7th, that means that I'll be able to choose the final exam of the best projects who can skip out on the final by the end of the week, by the end of that week. So turn it in on the 7th. By 11th, I'll notify the best projects. Okay. So, and then, yeah. So the final exam, we're going to be reviewing for that today a bit. I plan on asking, so far I have 3 questions chosen for it, 3 larger size questions. So, is there a grading rubric? I have to do that. The video, it would be about you talking, basically talking about it. Let's see. I'll send out a rubric tonight, what I want for the video. Instructions as well. So that way that way you can know what you need to do. Okay. But it's a bit of both, showing off what your final project as well as just talking about what it was, but it should be a very short video. Okay, I'll send out all that stuff. I'll send out all that stuff about it. So, okay. But mostly if so long as you've put in effort and we've seen that you've put in effort, even if you've failed to complete what you set out to do, as long as you put in the effort and there was progress made, that will probably render a pass for you on the final project. So, because again, part of this is being very difficult, or finding difficulty in what you set out to do. All right, with the final exam, any more questions about the final project? All right. So again, no, it's not graded on a pass fail. For the most part, I will have some kind of rubric, but I mean, in general, I'm going to try to get a more solid rubric out tonight for myself and the TAs. All right. Let's see. So let's talk about the final exam. Final exam has a couple different topics. Let's go ahead. Preferences. Font. Yeah, I installed a new hard drive, so I haven't installed all my fonts and stuff yet. Okay, so let's go ahead. Yep, that's been, all right. So for the final exam, I plan on asking about, I might be a bit lazy in this and ask only 3 questions, but 3 big questions. So let's talk about these questions first off. Right, one I've already kind of told you about, which is, so let's go ahead and look at one. One is basically file. One big question will cover file reading / file writing, and this will be done on Canvas, by the way. So you'll submit your answers via Canvas. File reading, file writing. It will also cover string parsing or regex, depending on how you think about it. So basically, it's something along the lines of, the question will be something along the lines of, given a text file, replace all private information with, create a new text file that is the same as the original text file, but with all of the personal info redacted, which means removed. So it'll be something along those lines. The only question is what is personal information in this? So in the example we saw, it was a social security number, right? In another example, it might be a phone number, or it might be temple email addresses. Probably not. I'm telling you what to prepare for what kind of problems to prepare for. So reading, writing, and removing and doing the substitution. So going back to the regular expression video where I removed and we saw that took only like 7 lines on my part, and the hardest part was figuring out what the regular expression was. And if you don't want to use regular expressions, it becomes a lot longer, but it's doable. Okay. So with all the personal information redacted. So it might be a social security number. It might be it might be a phone number. It might be credit card numbers. It might be temple email addresses. So, those kind of things. Okay. So second question is going to be along the lines of something you haven't seen before, something new, or something we briefly mentioned. Here's instructions on, here's how to use it. Here's how to use it. Use it to complete this specific task. So basically, it's basically kind of a test of how well do you understand programming to use this new thing, which does exist in Python, right? So I am going to use something built in Python. So you're able to look at all the documentation that you're going to want to, okay? So, but it's something that we haven't covered, but it's not going to be particularly hard. It's just going to be novel. And so this is a test of, have you learned how to absorb information and apply it? Okay. So that's what, so this one will test, it will test probably for loops because you'll have to use it. It's not going to be anything crazy like lambda expressions. So 3. And the third problem I've thought of is Monte Carlo approximations, which will be the bulk of today. And that problem will be basically, here are the rules for a game. What are the chances of victory? That's basically what the question is going to be. It's given here's a question, right? Here are the rules for a game. What are the chances for victory? I will most likely give you some basic children's game of some kind, and I will be asking, and it's not going to be particularly hard to model. It may have to give you some code just to get you started simply because of that. But for this one, you'll definitely want to remember about tests. Let's see, for loops, lists, or conditions, and what else will test? Edge cases, for loops, list of variables, conditions, edge cases, and what else? So did I go over Monopoly, by the way, in this? I forget. Did I go over the Monopoly problem already? No. Okay. All right. So let's take a look at so I'm going to pull up a problem along the lines of what we did last semester, okay, for an exam. I think I talked about it, but I didn't necessarily go over it. The final is open, period. It is the same rules for that you've had for the okay. It is the same thing. Okay. So it is the same rules that you had for your quizzes. So let me get back to let's see, do I even have Git on this? I don't think I do. So let's go ahead and do teaching, ITP. Yeah, last semester I had like another turtle problem on there, but honestly, I want to keep this one short based off of what I've experienced from last semester. And I think just having 3 problems that test basically everything will be sufficient for this. So let's see. That makes sense to everybody? Just having some larger style questions that I can have very strong rubrics on and give and say, okay, it's these conditions that you get for partial credit on this stuff. So let's see. All right. So here we go. This is from the actual exam from spring. Okay. So in the board game Monopoly, for those of you who don't know, and if it's a complex game, I'll be focusing on something smaller like this. In the board game Monopoly, players move around the board by rolling a pair of six-sided die. So you roll two six-sided die, rolling doubles. So in other words, rolling a 3 and a 3, or a 5 and a 5, or a 6 and a 6, or 1 and a 1 is really good in Monopoly, because that enables you to basically get a second turn essentially. Okay, where is my chat window? Did I move it over here? Sorry, the chat window always seems to disappear. Yes, you can paste your code into a text box in Canvas, and there will be an optional file upload at the end, so that it'll be a 0-point question essentially, where basically you can upload any of your files that you used. The only difference between the final and the quiz, okay, is going to be the fact that we're all taking it at the same time, and I'll be there to answer your questions. That's really the only difference. Okay, so in the board game, we care about rolling doubles, such as 2 5s or 2 3s. It won't shut down, but it will be marked late. If a player rolls another set of doubles, this allows the player to get another set of turns. So you get the 2 hours that are allotted, and then and then I have this on my late penalty, which is 0.1% per minute late. Okay. So player rolls it. So basically, if you roll a double, you're going to get another turn. If you roll a second pair of doubles, you get yet another turn. But if you roll 3 doubles in a row, then you get that basically basically the game throws you in jail. I ran the grades. I will answer those questions, but let me finish describing this. Okay. So, if the player rolls another set of doubles, this allows them to get another turn. So basically, you can roll the dice. You can end up with no doubles. You can get 2 turns essentially by getting 1 pair of doubles. You can get 3 turns by essentially getting another set of doubles. And then if you roll that 4th set of, but if you roll that 3rd double, then too bad, so sad, you're going to jail. So write a program that simulates 100,000 Monopoly turns. Extra rolls due to doubles count as part of, I worded that bad, but it's basically part of the same turn, where a turn is a single roll of the die or more if a user rolls double. So here were the rubrics for this. You had to simulate 100,000 dice rolls, handle doubles, handle 2 and 3 doubles in a row, and 2 points to present it in percentages. So I'll give you a breakdown for all the questions as to what I'm looking for, because that helps me when I go back and grade. So let's start with the first thing. Let's simulate 100,000 dice rolls. Okay. Now to answer the first 2 questions that came up, will Runestone be run again? I just ran it this past Sunday. I will run it again on December 7th. If you need to demo a lot of assignments, then yes, you can still submit them, but it's up to the mercy of your TA at this point, depending on how late they are. Okay. So let's go ahead and simulate 100,000 dice rolls. So for blank in range 100,000, that's how many simulations we want. Pass. Let's see if this, okay, boom, and good. So it's running just fine. Okay, and let's go ahead and print done. Okay, that prints out done. Let's go to settings again and up the font size. So font size. Okay, there we go. Much better for everybody to see that. Okay, so for IM range 100,000 pass. Print done. So now we need to simulate 2 dice rolls, right? This says simulate a dice, simulate 100,000 dice rolls. So let's go ahead and say die 1 is, or let's go ahead and say D1 is equal to, well, random import random. I'm going to go ahead and create another function over here. Def, let's call it D6, which is short for, which is RPG shorthand for 6-sided die. Turn random.rand int, and this will give me a number 1 through 6, right? 6-sided die. So that function will do that. Make sense? Second one, let's do D1. Let's go with die 1 is equal to D6. Let's be more specific. Roll D6. Roll D6. Die 2 is equal to roll D6. So here, and let's go ahead and look at this. This simulates 100,000 dice rolls, right? So there you go. That was 10 points. No problem there. So now handling out of 20, by the way, handling doubles. Now, how do we handle doubles? Okay. How do we handle doubles? Well, what we have to do is say basically if die 1 equals die 2. So how do I want to handle it? Well, the program wants me to keep, the problem wants me to keep track of the percentage of rolls without a double, right? Then percentage of rolls with 1 double, then 2 doubles, and 3 doubles. So if die 1 is equal to die 2, then doubles is equal to 0. And we'll just simply say if die 1 is equal to die 2, doubles plus equals 1. Make sense? So that should handle that. Else, let's keep track of the non-doubles. Singles. Singles plus equals 1. All right, so if die 1 is equal to die 2, okay? So now if I look at, again, this whole thing where it says handling doubles, simulating, so that's 15, that's 3/4 of the points right there. So now I got to handle 2 and 3 doubles in a row. Well, you only get 2 double, you only get to roll a second set of doubles if you've rolled 1 set of doubles. So what we have to do over here is that, right, what would happen is that you would roll again. So let's go ahead and roll these again. And then basically ask ourselves, again, if die 1 is equal to die 2, all right, and yeah, there's a logic mistake here in just a second that I'll have to fix. Then let's call it triples for 2. Let's go ahead and call it actually. Let's call it 2 doubles. And I suppose I should. No doubles. 2 doubles is equal to plus equals 1. So here, right, I rolled the same thing on both dies whenever. Rolled the same die on this guy. And then if they're the same, we increment the double or the 2 doubles. So here, though, the question is that I would ask the professor if I was taking the exam. Does a 2 double turn include all the stuff where we rolled 1 double? Well, it would roll more than 100,000 times. But what we said over here, and I said it poorly, but what I said over here was a turn is a single roll of the die or more if the user rolls a double. So a turn, right? So we're simulating 100,000 turns, not rolls of the die. Those extra turns are technically part of the same turn. Okay, so now, however, because this is basically, we would double count our doubles over here, what I'm going to do is simply say, if we don't get 2 doubles, right? So here, in this case, we get 2 doubles in a row. This case, we get 1 double in a row. Now, how do I handle 3 doubles? Exactly the same way, with exactly the same rearranging. There we go. So here, what I do is I declare all these variables. Okay. So let's go ahead and try this. Print. Let's go ahead and try this. So here I want to print singles divided by 100, or I called it no doubles. No doubles divided by 100,000. Doubles. 2 doubles. Now the reason for this is so the reason it's structured like this is so I don't double count anything. I don't double, I don't count all the 3 doubles and the 2 doubles. Let's go ahead and run this, and we see that this is about the so here let's do some just basic checking. So 14% about for these, okay, for getting a single double. Now let's think about that for a sec. What are the chances that 2 things are the same? If you roll two 6-sided die, what are the same? Well, it'd be 1 in 6 that they're the same, right? There's 6 different ways out of 36 that they can match up. So what is 1/6? So Python 1 divided by 6 is about 16% as opposed to 14%. But if we look at this, we have 14% over here plus another 2 and a bit. So that matches up just fine, right? Because we can only get these if we rolled it for a double other time around. So you roll, so a turn with 3 doubles happens about 0.5% of the time, and a turn with 2 doubles happens about 0.1, happens about 2% of the time. Although again, I did say to present the data in form of percentages, so let's go ahead and do that. Times 100, right? And then let's go ahead and throw that into a string. And plus. And tack on a percentage sign after that. STR. STR. And then what we can do over here is we can just simply take this. And there, now we have it in percentage. Oh, right. I have to do times 100 over here. And now it's in percentages rather than, and such easy to read. So there we go. All right. People want me to do another Monte Carlo problem? Give me 1 second. I want to get my data to be as real as possible. All right. So let's go ahead and do another one. Versus goblin.py. All right. So I am a big fan of a game called Dungeons and Dragons. Because I'm the teacher, I get to choose the game that we're playing around with. So Dungeons and Dragons is basically a collaborative storytelling game, one of the most popular tabletop RPGs on the market these days. And there is a quite hefty amount of math behind it, but it's but doesn't really get in the way of playing, especially since how much has been simplified today. Most of the way the game Dungeons and Dragons is played is that if there's a chance of failure for an action, you roll what's called 1d20, a 20-sided die, and then you add a modifier to it and compare that to another number. So 1d20 plus another number, or a 20-sided die, right? Like this guy. This is a 20-sided die. I do not. You roll, never even heard of it. But roll 1d20, add a number, compare it to a target number, and it works. And you see whether you succeed or fail. One of the most common things in the I DM a lot. I end up being the DM a lot, unfortunately. And I've been banned, and I think I've been banned, but from my friends from playing Bard because I break things in the game. A lot of the time, yes, I'm a forever DM. So one of the most common things for adventurers to fight in their first adventure are goblins. Goblins are these nasty little critters, and they just, you know, for when you're starting out, they're quite dangerous. So let's take a look at actual statistics from this game, and I'll show you where it comes up. So to hit a enemy in Dungeons and Dragons, you have to meet or exceed what it's called the armor class. So here, a goblin has a 15 armor class. So you have to roll. So you have to do the d20 plus the modifier, right? Roll a random number, and add the modifier, and it's got to be 15 or more to hit it. Okay, so other stuff is unimportant for right now. So let's go ahead and see, would a first level fighter, one of the more common classes for Dungeons and Dragons, but for players, be able to hit this guy? Now, so let's go ahead and first just simply simulate roll d20, right? Before we talk about first level fighters and stuff, and I'll provide that information, which I would do on an exam. So let's go ahead and see def roll d20, which gives us a 20. So that's just simply so I don't have to keep typing random all the time. This will just simply return random.rand int 1 to 20, right? That's all d20 is. Let's go ahead and import random. Okay, so next is, what is the next is, how does what does a first level fighter typically look like in Dungeons and Dragons? And because for some reason I have like a ton of these things memorized for no useful reason whatsoever, a first level fighter typically has a 16 strength, which means that his strength modifier is a +3, which and if we're playing in 5th edition, that means that his first level proficiency modifier is a +2, which means a total +5, meaning a roll is 1d20 +5. So for your standard first level fighter, and if he's using the dueling style, which we'll have to talk about later, he will do 1d8 +5 damage on a successful hit. A common game? Probably not, but it'll be a lot simpler. A lot simpler. The game I am thinking of for simulations, and I gotta check the complexity of simulating. Yeah, the game I'm thinking of is one that is the first board game I got for Laser. Okay, and so it's a game designed for 2- and 3-year-olds. So there's an element of random chance in there, but it's but all right. So, all right. So first off, this is what basically we want to see. So for the first part of our things, we want to ask for our question, basically, how often does our first level fighter hit? Does 1d20 +5 hit a goblin? And I'll just simply use target is meet or exceed 15. And not does, because it can. How often does that hit a goblin? All right, so let's go ahead and simulate. And let's go ahead and simulate, do simulations is equal to, right, 100,000 simulations for blank in range. I just created a variable. I should use it. So, so we call this an attack roll. So that's what I'm going to call as a variable. Attack roll is equal to roll 1d20 +5, right? That's what our so that's right. That's what I was saying. What we do, you take it and we add 5. This is information I've given to you. The +5 is just simply given to me because I know how to play this game. Okay, so let's go ahead and see what our statistics are for this, for getting this roll, because it's not. We've got 20 things here. Storing that in 20 different variables is pretty nasty. So what we're going to do instead is I'm going to create a results is equal to a dictionary file. And what I'm going to do is I will just simply say, hey, if attack roll not in results. So in other words, have we rolled this number before? If not, well, we've rolled it once now, so we'll say that we've seen it once. Otherwise, well, I'm going to get the number of times I've seen it before. And add 1 to it, which I could just simply simplify to, right? So if I've not seen it before, if I've not rolled this number before, I've rolled it once now. Otherwise, I've incremented the amount of times I've seen it by 1. Print results. This will be ugly. So let's go ahead, and we see that we've got a bunch of numbers and they are out of order, but that's fine for right now. For I in range results, print I, print I comma results of that number. Dict cannot be interpreted as an integer. Yeah, this is what happens when you don't program for a week. So we see that that these are the roles we get, right? Makes sense? Okay. So, and we see that because it's a 20-sided die and the die is unweighted, basically that everything comes up with the pretty much the relative same value, which is about 5% of the total numbers. 5,000 out of 100,000, right? Let's go ahead and print our results sorted, which is something I always forget how to do. So this is part of the reason why I'm a believer in having notes and the like, or open exam information, because I don't remember everything. So I'm literally going to look it up right now. Print items from dictionary Python sorted. So, nope, not what I want. That's sorting a list. It's a dictionary. Print a dict sorted by values. One advantage is that sort works on tuples by considering the first element. No, that's a list comprehension. I don't want to do that. Use the key. Oh, but it's sorted by values. Sorted by key. That's Python 2, Python 3. Key is equal to F. Really no pretty easy way to do it. One that I don't really have to explain. Oh, actually, that one's fine. Okay. Yeah, no, that makes sense. So results.items, if you remember, if you stretch your memory way back when, that prints out, that basically gives me that gives me basically every single item from this. Sorted results. Well, let's go ahead and see what sorted results would do. Yeah, it might just be that simple. Let's test it out. Yep, that's as simple as it needs to be. Here I am trying to overcomplicate it, when generally the first instinctual answer in Python is the correct one. Results, I. Oops. Nope, I don't want this one. I want to... Did I seriously just do that? Python files. Okay. Yeah, so there we go. And the reason for, so now let's go ahead and see basically how many times, so I'm just simply setting this part up for later. Let's go ahead and see how many times we are going to actually hit the goblin though. So how often does this fighter hit the goblin at first level? So let's see if attack roll is greater than or equal to 15, hits plus equals 1. That's all we really need to keep track of. We don't need to keep track of any misses. Print hits by number of simulations. So how often does this fighter hit? He hits about 54% of the time. Okay. All right. So he hits about 50% of the time. All right, let's go ahead and now ask ourselves, okay, when a fighter hits a goblin, you then roll to see how much damage you do. Standard weapon of choice is a longsword in Dungeons & Dragons, which is actually badly named because technically a longsword is something that you use in 2 hands as opposed to something that can be used in 1 or 2 hands. But I digress, and I'm being pedantic here. Point is 1d8 plus 5 is the amount of damage that we do. So let's go ahead and basically see. So now that if we hit, let's see how much damage we do. So if we miss, so let's go ahead and actually pose ourselves a new question, which is, what are the chances that a first level fighter can one-shot a goblin? Okay. To kill a goblin, you need to, you have to do 7 points of damage to destroy its hit points. So 7 points of damage, which means you have, on your 1d8 plus 5, you have to roll greater than, you have to get 7 or more. So if you hit, and leave any complicated questions as to why are we fighting goblins? You know, can't we just talk? Leave that for later. Attack roll is equal to random.rand int 1d8. So it's 1 to 8 plus 5. All right. Is equal to so that's equal to damage roll. All right. If damage roll is greater than or equal to 7, let's go with 1 shots is equal to plus equals 1. Okay. Now let's go ahead and do so the chances of getting a 1-shot on a goblin in total is equal to a 48%. So if he hits the goblin, it's very likely that the data is saying that it's very likely that that the goblin is done for, which makes sense, right? Because 1d8 plus 5, the lowest you can do is what? What's the lowest you can get on that? 6. Yep. So you'd have to roll a 1 on that to do that. But now let's go ahead and see what our, so let's go ahead and see exactly how much damage might be done against this thing. So instead, what I'm going to do is I'm going to use results. And I will just simply put in with, we have, and results is going to keep track of not of hits, but our damage rolls. And let's go ahead and define basically a miss as 0 damage. So if the attack roll is greater than or equal to 15, then we do a damage roll. Else, we missed it. So our results for getting 0 on damage is equal to plus equals 1. Right. And so now over here, what we're going to do is that if rather than keeping track of like how many one-shots we get, what we're going to do is we are going to keep track of all the damages that we get. So damage roll is equal to results. So if damage roll in not in results, if we haven't rolled this number before, then results plus equals, sorry, results of the damage roll is equal to, well, we've seen that damage roll one time now. Otherwise, we've seen it before, so just simply increment the number of times I've seen it by 1. Okay. And I don't have to do that over here because I already initialized 0 over there. So now what I can do is I can say, hey, here are the values we get, and let's go ahead and do results divide by simulations. Results divide by simulations plus, and then let's go ahead and put it into a string to make it easier to read. Results plus the percentage sign. Oh, and yes, multiply by 100, of course. And now, oh, right, gotta scroll down. So here we see that basically that we are getting 0 damage 45% of the time, which makes sense if we're missing 55, if we're hitting 55% of the time. If we hit 55% of the time, then we're missing 45% of the time, which means 45% of the time we're dealing 0 damage. And then all the other damages are around this amount. Of course, a longsword isn't all that now this isn't that particularly interesting because we're rolling one evenly distributed, evenly weighted die over here. Not too interesting. So let's go ahead and ask, what if we use what's called a greatsword, which is a different kind of weapon in Dungeons and Dragons. Weapons are defined by the fact that basically you do 2d6. Sorry, a greatsword, you do 2d6 damage. So in other words, you've got to roll 2 6-sided dice to do that. So let's go ahead and steal the roll d6 because otherwise it's going to look really messy. So let's go ahead and see. And of course, if you're doing that, you don't get the dueling fighting style, so that goes down to 3, right? More information you don't necessarily know. And the funny thing is, I haven't played Dungeons and Dragons in like a year, and I still remember this stuff. Why? Why can I remember this kind of stuff, but I have so much trouble remembering students' names? So here we do 2 of these. And roll this. And now we can see that actually that the data, while the hit is the same, the amount of the rolls changes quite drastically, right? You get a much more bell curve distribution of that data. That is true. I do like my Dungeons and Dragons. I do like my students too, though. All right. So you can see that basically given rules, it's very, and dice rolls, it's very easy to simulate your dice rolls. All right. I'll be back. We're going to grab one of Laser's games to do one more problem before we leave. And it's not the one I'm going to do for the exam. I was actually going to do that one for the exam, I think, which is calculate how often the crow wins. This one. So I got this game off of Amazon for like 20 bucks. It's called Outfoxed. Laser particularly likes it. I'm showing them your game. And basically it's a whodunit cooperative game where you play, where basically you're a bunch of sleuths trying to figure out which of the foxes stole a pot pie. And it's basically like Guess Who, where you go around the board and try to collect things. So the way this works is that you've got a board. No, Guess Who, as in you flip down stuff. Clue is where you search for clues and you're like, and you're putting stuff down. Right, and basically you move your board around, you move around the board, and either you reveal clues and you put them into a little thing that is really cool. Yeah, you can see it. You can come over here, Laser. All right, or you reveal suspects. You want to show them the way the card works, Laser? Mm-hmm. Okay, right. So you put the card in here.
Then new. But my dice.
Well, we're not showing them the whole game. We're just showing them the dice rolls. So you put a card in here, and then Laser, do you want to slide this open? Mm-hmm. Yeah. So let's see. So you slide it open, and it's got these dots in it. Can you show the camera, Laser? Show the camera. It's got these dots in it. You put this over on it, and it will tell you whether or not the fox is wearing this particular item. And so because it has a green dot underneath it, which you can't see because I'm trying to keep it in frame. Does it have a green dot? Mm-hmm. Yep. So we would know that the fox that we're looking for is wearing glasses because that's what this has. Right. And so, and then at the end of the game, you try to deduce who it is, and it has the name of the fox in it, which is Henry. So now, the main mechanic for this game that's chance-based is using these dice, these special 6-sided dice. And okay, so 6-sided die, right? It has 3 eyes, 2 1-foots, and 2 1-foots and 1 2-foot. So here's a 1-foot. And here's a 2-foot. Okay, so this is what we're going to be simulating. We've got 3 of these D6s. Okay. Now the way this game works is as follows.
How it works?
How does it work, Laser?
I don't know how it
works. All right. The way this game works is that you roll. It's the way you do an action is that you declare you're either going to look for suspects, which is the eyes, or you're going to roll the, or you're going to roll the, or you're gonna look for suspects, and you're gonna look, and you're gonna try to get the feet. So you look for, if you look for suspects, you try to get 3 eyes. If you're looking for clues, you try to get as many feet as you can. If you get 3 tries to roll, and if it doesn't match up, then the fox gets closer to escaping. So the way it would work is, let's go ahead and grab this, is that, say I wanted to look for suspects, I would roll, and okay, I succeeded that time. Say I wanted to look for clues. So here I had 2, whoops, it's hard to keep in focus with the camera over there. So here I was looking for clues. So I got 2 clues and 1 eye. That's not good, but I've got 3 tries to do it. Well, we can play afterwards. So I roll again, I got an eye, and so here's my 3rd and last try. Okay, so that means I do get to look for somebody this turn. So, and if I don't get it after the 3rd time, then I don't get to do a turn. So here's the question: how often will I fail? How often does the fox get to go closer? How often will I fail at doing that? So let's go ahead and create a new file. We may not finish this today, but that's okay. Outfoxed.py. So first off, this one is that basically we need to figure out we have to write our method for rolling the die. Import random, as we need to. So here though, the dice, yeah. So for the purpose of this question, yeah, we've got, 3 eyes, 2 1-foots or 2 feet. But honestly, the feet just the difference between a 1-foot and a 2-foot is that you get to move as many spaces as there are feet. So for the purposes of this exercise right now, you can just consider it as feet and eyes. Okay. So let's go ahead but honestly, yeah, we can just simply simulate it as is. So let's go ahead and def roll. So, and now we have to basically create here we actually have to create the die. Okay, because it's a custom die. Right? Here our die is 3 eyes. So I foot. Let's call it foot. And actually let's call it a 1, and a 2. Make sense? You're opening up the board? It's adorable. Okay. So here's our die. And now how do we get a result out of this? Well, we would return random.choice of the die, which will choose something from random from the die. So print roll. Print roll. Boom. So here, that was a 1-foot, an eye, a 1, an eye, and a 2. So we get everything there. Pretty cool, right? So we were able to create a custom die, right? So next, let's go ahead and look at simulating this. Laser, don't bang your board so hard with the toy. Okay, def. So let's go ahead and do simulations is equal to 100,000 simulations, right? Now, let's think. So what we need to do basically is that we have 3 die, 4 eye in range simulations. Let's see. In this case, we have to roll these dice. So well, first thing we got to do is actually roll the die. So I'll call them A, B, and C. Die. So roll. So here's our 3 die, A, B, and C, and they're going to give us different results because it's random. So now what do we have to do? Basically, we have to see, okay, are they, we got to check basically, are they equal? And what's useful over here is notice that I got a bit clever over here accidentally, which is that notice that 3 sides are strings and 3 sides are integers. So we could use that to our advantage, but also we can just simply note that basically that we have to declare what we're looking for before we look for it. And because the chances of moving versus the chances of getting a suspect are the same. Oh, it's set up to play? Can you get Mama to play with you? Because I'll play with you in 10 minutes. He wants to play.
What do you want to play?
Outfoxed.
So you brought a game upstairs and he wants to play.
Yes, he does want to play.
I am so surprised.
I know. I should have seen this one coming.
And I'm going. Well, and you're going to be queen.
So
You be queen.
so the
Yeah.
so let's go ahead and assume that we're looking for suspects. If
You want to take the game over to the activity table to play? That's still teaching.
so let's go ahead. So this is the tricky part to simulate, which is okay. If A,
Then we have to just need
if
this only.
A equals I
This.
and B equals I and C equals I. And that's what we want. We want all 3 of them to be I's rather than just trying to compare those, the feet. So that would be a successful roll. Let's call it success. It's equal to 0. Success plus equals 1. Else, otherwise we get 3 tries to do this, which is that if A equals, there's probably a nicer way to do this, but this is going to be ugly. If A is equal to I, if A is not equal to I, we're going to re-roll it. If B is not equal to, oh, that's a better way to do it. Yeah. We re-roll it. So I'm going to finish writing this out. And if C is not equal to I, C gets rolled, right? Because we're looking for I's. So here, what I'm going to do is I'm going to get rid of all this. Put these over here. Okay, and here it's saying, hey, you don't have those defined, but I'm about to actually do that. So if A is equal to 0, B is equal to 0, and C is equal to 0. So I'm just going to start them off as that. Can I equals, oh yeah, you can do if I is equal to A equal to B equal to C. I believe you can do that in Python. Okay. And then what I'm going to do, for I in range, for blank in range 3, you get 3 tries to do this. Success, and then break. Okay, so how does this work? Okay, so each simulation is trying to get 3 of these things to line up. You get 3 tries to line them up. So I initialize them to say, hey, I haven't rolled anything yet, right? And what I'm going to do is that I'm going to try and get the eyes, because that's the same chances of getting 1s and or 2s. If I wanted to check that, I would just check for integers. So for blank in range, so for blank in range 3. So first off, we're allowed to lock our die. So in other words, we get so once we roll, it comes up on the side we want, we're allowed to opt to not re-roll it, which of course, if it comes up on the side we want, we don't want to re-roll it. So here we would go, if it's not an eye, roll it. Not an eye, roll it. Not an eye, roll that die. So here we'd be rolling them all individually, but that's fine. And then if they're all the same, we got a success, and then stop trying to roll your dice. And if you don't, we're not going to keep track of it. So, and so here, what we're going to see is print success. Whoops. Print success divided by.
The dice.
You need the dice?
Here
you go.
Dice.
Success divided by simulations. And it says you did not succeed at all, which does not. If A not equal to I, roll. So let's go ahead and print yay to double check. Oh, yeah, I do have that. That would always be false. Good catch. So 69% of the time, we will have a successful roll. So it's weighted quite in the favor of the individual playing. 67. I'd actually say that's about 2/3 of a chance. 2/3 of a chance of success, which seems about right for my playing with laser. So this is so the important thing, though, I want you to get over here for the final is remember about random.choice if you have to construct your own dice. Hint, hint, nudge, nudge, wink, wink. All right, so because for a lot of children's games, there are not standard 6-sided dice, or there are dice with 6 sides, but they replace the shapes with maybe colors or something. All right. So it is 3:18. My child desperately wants to play board games with me. I will do some more review. I'll aim to do some more review later on Thursday for the exam. And then I will plan on giving you your rubric tonight. So look for emails from me. All right. Have a great day.
Thank you.